Warm up. Shooby-dooby-doo. Did you have a good fun weekend? Did you have fun? Good. Has homecoming for some of your seniors? Yep. No, is that not the same? Oh, oh, shoot, sorry. My bad. Do the one in the box. Sorry about that. Thank you, Olivia. I forgot that I had an error there. Which variable do you definitely want to use? If you use x and on the y-axis, what's mean? Sure. Did you get 32 pi over 15? Oh, sorry. Keep going. my time, my key, I budget, you guys will take about 1.5 times the time I take. It's not that I'm fast, I'm not, it's that I know the questions and what the question's asking right away. But my point is that you need to practice without a calculator, because you're going to have teachers and professors that learned all this without a calculator, and that's what they're used to. So you need to be able to do that in a fairly quick way. Okay? Any questions about where we're coming from there? We good? Okay, so you can see that your test is Wednesday. Your test, now, I would have loved to have had a test last week because that's when it should have fallen, but tests in the homecoming week don't tend to go well. It's hard to do a test when you are wearing a toga or whatever. And it just doesn't go well, so I'm giving the test Wednesday. Now that said, normally when I make the test is a mixture of the straightforward book stuff that I want to see if you learn, and then a mixture of also AP kind of stuff. But because there are so many sets on this, it'll be predominantly just straightforward. Do you know the concept, basically, not with an AP twist, with some exceptions. Because it's going to be straightforward booky, this will be your review right now. Here we go. There will not be a practice test. So the test is through 87. Let's work on down and talk for 5 minutes about what the test might look like. 87 is shells. I will give you, because it's new, I will give you a pretty basic one, probably even easier than this. Will that go okay? Yeah. Okay, cool. 86 is even and odd functions, particularly integrals. There I advise you don't cut corners, don't feel like, oh, these should be easy, I can do this all mentally. That is the kiss of death on those. You should do things well and slowly and methodically. But 86 is even and odd, especially pertaining to integrals, okay? 85 is MVT. Now that actually could be straightforward or AP style. Straightforward in the book, just make sure that you say the conditions are met. The conditions are that the function is continuous on the closed, the differentiable on the open, and then you do the MVT. You should also be able to do AP style because we did a full homework on extra practice 85. That also should be good. So I might give you an AP free response involving the anxiety theorem. I'm not sure. 84 is logarithmic differentiation. That could be take the derivative of x to the x. Anytime you have a variable in the exponent, you should consider logarithmic differentiation, right? It could also be a case where it's just some hideous chain rule, product rule, quotient rule mess, and you use logs to blow it up into lots of long fractions, and then you take the derivative. Are those clear? Have those been going okay? Okay. 83 is integrating even powers of sine and cosine. Now, I'm not big on studying for math tests, but that is definitely a thing that if you don't have those in your brain now, you've got to have memorized the power reduction identities for the test. If you don't know how to get from sine squared to that identity, not how to get there, just that it equals that, and then how to integrate, then you are going to have a hard time. So make sure you have those down cold. You good? Okay, you probably have those in your memory now just by virtue of doing the problem solving. That's 83. 82 is differentiability and continuity. That could be a straightforward, here's this piecewise function with A and B or some unknown constants. Find A and B to make it continuous and differentiable. Are those going okay? So those are pretty common A3 questions. And you've been doing them in the homework. Differentiability will also be, I'm just going to tell you, it's on the test, prove the function is not differentiable by using the definition of grid. You need to be able to do that. I don't have one of those on the homework, I don't think, but we will do one tomorrow to make sure you're consolidated. You good? That's 82. 81 is volume by washers. How's washers? Okay. Pi big R squared minus little r squared. 80 is rational functions with slant asymptotes. Can you divide to find the slant asymptote? And then graph effectively. Yes? I will not do parabolic asymptotes. I know we had two of those in the homework, but I will not go there on the test. It's not what I would consider a huge part of the class. All right? So slant, we're good? 79 is L'Hopital's rule. We're starting to get into stuff you've been doing for quite a while, and yet I still haven't tested on L'Hopital's rule. L'Hopital's rule, I can guarantee you it'll be a indeterminate form that is not in behaviorish. I think there was one on the homework last week that was something like this. Something like that. Do you agree that by end behavior you could just say, oh, that's going to approach -1, yeah? I can assure you on the test you will not be able to do that. You need to know L'Hopital's rule. You need to show effectively it'll be a problem that you must use L'Hopital's rule. Understood? Okay, make sure you show quality work. And then 78 is motion problems, velocity, acceleration, distance, displacement, speed. How do you show speed is increasing? Speed is increasing if velocity and acceleration have same sign, and decreasing if velocity and acceleration have different sign. Distance versus displacement. That's another AP free response possibility. That's very common. I might pull one from that. And then 77 is the last new material on the book. That's work. Can you do work? Pump fluids out of a container. Can you keep that straight with fluid force? So maybe we'll have to do both. Is that going okay? Do we need a 30-second review of that? We good? All right, then your silence says excellence. Okay, so the test will go great. You're going to kill the test, and it'll be super duper easy, and your mom will be so proud of you, and she'll put your test up on the fridge, right? Wrong, because you can't take the test out of the room. All right, no more fridge. So, separable differential equations. This is a big deal of calculus, a really big deal of calculus. So big that it's actually a chapter in most calculus textbooks. This is a whole chapter. It's got probably maybe four lessons to differential equations. This will be an intro. And we'll do some more tomorrow that I pull from an AP and a college course. All right, so first, though, let's go with differentials. What's a differential? It would be super if when you went to solve differential equations, you knew what a differential was. I find that much easier. So what is a differential? Give me an example of a differential. Yes, there's a differential. There's a dy. Okay, I'm sure that when Miss Cannon introduced the idea of derivative, she would say the slope between these 2 points is delta y over delta x, and that's change over an interval. But if this point gets closer and closer and closer, then that delta y and delta x on the most minuscule kind of triangle becomes this more theoretical dy and dx. This was done by Leibniz, not Newton. Newton didn't use differentials. And therefore, Leibniz's notation is actually a little more applicable to lots of things. All right, so that said, what if I put that on the test? Who are the two creators of the calculus? Could you do that? No? Yes? Leibniz and Newton. There you go. Cool. Where Leibniz was German, English, Dutch? German. German. And Newton was obviously English. All right. So, it's important that you know the creators of the calculus. That said, differential equations are anything that involve a dy or a dx, or in some textbooks, even just y prime, especially the Rogowski book, which they use in Mines. They use y prime notation. So these are all examples of differential equations. Dy dx equals 5. That's a differential equation. Dy equals 4 dx. That's a differential equation. Y plus y prime equals 2x. That's a differential equation. It's got a derivative or a differential in it, or both. Those are all examples of differential equations. You follow? All right. Now, this is important. It seems so easy, but this is important. When the question will almost always read, solve the differential equation. And every year, I'll get a student, even late in the year, come up to me and say, what do you mean solve the differential equation? Because solving a differential equation is very different than solving an equation like you've been doing for 10 years. When you solve an equation, here, if I solve an equation like x plus 2 equals 4, then what's the solution? X equals 2. And what makes that a solution is it's the value of x that makes the equation true. When you solve an equation, you're saying this is what makes the solution true, or makes the equation true. It yields true, right? Solving a differential equation is not the same. When you solve a differential equation, you're actually finding the original equation that yields the given differential equation. So when I solve a differential equation, the goal isn't to get x equals 7. The goal is to say, oh, based on this derivative you're giving me, the original equation must have been blah, blah, blah. You probably are thinking, well, haven't we been doing that? Anytime we undo a derivative, that's integrating. We've been doing that. That's not new. And you're kind of right. You're not wrong. It'll involve integrating. When we solve a differential equation, it'll involve integrating, but it'll be a little more. All right? So, I'm going to walk through a couple of these steps at the same time as we do this one. All right? So if I said solve the differential equation, the most important step, especially for AP purposes, is to show separation of variables. Yes, you want to integrate, but you definitely do not integrate it the way it is. Separation of variables means, actually I'm going to write it here, separate the variables means put the x and the dx on one side, y and dy on the other side. Constants can go on either side. Constants are coefficients on either side, preferably the side that makes integrating easier. And one more thing, would you please write yourself a note, the differentials must be in the numerator. Okay, so this is what I mean. The correct way to separate the variables here would be to multiply both sides by dx, so the x and the dx are together, and multiply both sides by y, so the y and the dy are together. That is the correct way to separate the variables. An absolutely atrocious incorrect way would be to say, you know what, I'm going to just leave the x and divide, I'm going to divide over the x to get it with the dx, and I'm going to divide over the dy to get, that absolutely is bad. You never want differentials in the denominator, ever, 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 ever. Please don't do that. Are you with me? All right. Now, I then separated the variables. These notes are not structured. I don't like how these notes are structured. Not good. So I have y dy equals x dx, and I want to now solve the differential equation, which means to undo the derivative. So now I will integrate. And integration is just like all other operations in math. Whatever you do to one side, you've got to do to the other. So many homeworks. do it in a second. Okay, so when I integrate, I have 1/2 y squared and 1/2 x squared. And then the question is, well, what about the plus c? Do I need to put plus c on both sides? If I did put plus c on both sides, the next thing I'd do is probably get them together. It's arbitrary anyway, so you only need plus c on one side. I typically put it on the x side, just because sometimes you will solve for y, but we'll talk about that in a second, all right? Now, this is called the general solution. The general solution. The general solution is the best you're going to do if all they give you is the derivative or the differential equation. If all I know is the derivative, then it could be a whole family of possible original equations, all the same because the plus c would go away when I took the derivative anyway. You with me? Are you with me? Okay, but if they tell me, yeah, the shape based on the slopes has to be this, but I'm also telling you it also has to go through this point, well, then that's what nails it down to, oh, it can only be this one, not the others. So if they ask, or if they give you an initial condition, then you can find what's called the particular solution. You could say that just means find the c. So if I have 1/2 y squared equals 1/2 x squared plus c, and they're telling me that I can use the point 2, 4, then in for y goes 4, and in for x goes 2, and that tells me that c is 8 minus 2, I agree, 6, which means the particular solution is 1/2 y squared plus equals 1/2 x squared plus 6. That is now the particular solution. The one solution that goes through the point 2, 4. You follow? Notice I didn't solve for y because they didn't ask me to. If they want you to solve for y, then it's on them to say, I want you, well, they actually don't say it that way. If they want you to solve for y, then they'll say it this way. If they say find the particular solution y equals f of x, that actually means two things. Solve for y, and the answer should be a single function. Would you write yourself in parentheses no plus or minus, which I'll explain in a minute. All right, so in part C they're saying find a particular solution, solve for y. If I take 1/2 y squared equals 1/2 x squared plus 6 and solve for y, what would you do first? Multiply by 2, yielding y equals x, or y squared equals x squared plus 12, boy. Then what do you do for solving for y? Plus or minus and square root, right? Okay, now is that a single function y equals f of x? No, not a single function. I must choose. Choose based on the initial condition. If y equals positive 4 when x equals positive 2, I must choose the positive branch of the root. You can see that they said your answer is supposed to go through the point. Positive 2x, positive 4y. Well, the only way you're going to get positive 4 for y is if the original problem was positive x squared plus 12. You with me? Okay, now, What about somebody on the AP test who doesn't have super algebra skills like yourselves, and when they square rooted, they just had y equals square root of x squared plus 12. Do they get full credit? No, they lose too. First of all, they did bad algebra. Then they didn't demonstrate that they knew to choose the positive side. So no, you would get at best 4 out of 6. If you fail to show, yes, it's positive, and I'm showing you that I am consciously choosing plus, and they're not going to just give you credit for lucking out. You don't get credit for luck. You get credit for skill. So let me walk through a case that's more common AP style. So you have the differential equation dy dx equals negative 2xy. Find the particular solution to the differential equation given the initial condition. What's the first thing I'm going to do? Separate the variables. So when I separate the variables, should I divide dy over or divide y over to get the y's and the dy's together? Divide the y over. Never put a dy in the denominator. So dy over y. Cool. What about the x's and the dx's? How do I get them together on an opposite side? Okay, and then the 2. Can I take negative 2 over with the y? Is that okay? Sure. Can I leave it with the x? Is that okay? Sure. Which one's easier to integrate? Probably if you leave it with the x. All right, so in terms of the constants in the problem, choose what makes your life easier, and you can definitely make your life a nightmare if you choose badly. So make sure you think about that well. So if I integrate both sides, step 2 then is to integrate. The antiderivative of the left is log of the absolute value of y. Please don't forget the absolute value. If you leave off the absolute value, do you make the problem considerably easier? Yes, you do. And do you get a profit from your dump? No, of course you don't. And so you will be penalized heavily if you make the problem easier through a mistake like absolute value for getting negative x squared plus c. All right. If it said find the general solution, could I circle it, call it good? Yes, I would be done. But the problem didn't say find the general solution. It said find the particular solution. So we have to find the c, solve for y, and make sure my answer is a function. All of that is code in that one little sentence, find the particular solution, y equals f of x. All of that is implied within. So we still have work to do. Let's find the c. Finding the c, using that point there, f of 1 is negative 1. When x is, which one's the x, 1 or negative 1? When x is 1, y is negative 1 goes in. So I get log of the absolute value of negative 1 equals negative 1 squared plus c. Let's see. 1. Natural log of 1 is 0. And move over the negative 1. So now my equation is natural log of the absolute value of y is negative x squared plus 1. Now I need to solve for y. How do I get rid of natural log? Exponentiate. Does the absolute value go away when I exponentiate? It does not. Absolute value of y equals e to the negative x squared plus 1. How do I get rid of natural or absolute value? Consider this. Say I told you some number had an absolute value of 2. What would you know about that number? Could have been. Could have been either, and the absolute value knocked it out. So if I say the absolute value of something equals this, you have to think, well, it could have been either positive or negative. When you lose absolute value, a lot like a square, it could have been positive, could have been negative. And the square or the absolute value knocked it out. Now, we must finally choose plus or minus based on the initial condition. Given the initial condition is that when x is 1, y is negative 1, we choose negative. If 1, -1. I'm just basically writing a little note to the person reading this. Hey, I understand what the concept is. I know that I need to choose in order to make the initial condition, and this is what I choose. So the last step is really a communication. Is that understood? All right then. Here is Practice-a-Palooza here. You need to, first of all, find the general solution to the differential equation. Do those 3. If it says find the general solution, will you be finding C? No. If it doesn't say solve for y, do you have to solve for y? No. Just integrate and circle. How are we doing the first 3? Did you get something like those? Could you, what's that? Oh. Okay. Let me know if you disagree, if I have an error. And then go on to now finding the particular solution. Find the particular solution means you do what? Find the C. Do you have to solve for y yet? It doesn't say that. It just says find the C. Okay. For B1, did you get y equals 2 natural log of the absolute value of x plus 3? Yes? Okay, cool. Depending on where you move the constants, you could have slightly different numbers. I didn't move the 2 over on the second one. I left it with the x side. If you do that, you should get 1/3 y cubed equals 2 natural log of x plus 1/3. If you moved it over with the y, then it would look a little different. Are you good? Okay. Bless you. And then C is a classic trap problem where people do the constant wrong. They go too fast. Did you, for the last one, get C as -3, not -4? People think when you put a 0 in, it just goes away. That's not always the case. Y equals -e to the negative x minus 3. How are we doing? Good. Excellent. Now, these are more like you'll do completely, so you're finding a particular solution and solving for y. Choosing positive or negative. In some cases, not every problem has a plus or minus in it. I don't think that'll always be the case. All right, let me catch up to you, see if we're doing well here. Unlike the other ones, this you should have one answer for. There should only be one and two answers for. Okay. Did you get y or f of x equals positive root 4x plus 21? Yes? All right. And consciously choosing positive after giving plus or minus, right? Okay. How did you integrate to the left side dy over secant? Cosine, okay. So sine y equals x plus c. At 3 pi over 2, I'm looking at 1 equals 3 plus c. Did you get c is negative 2? So sine of y equals x minus 2, so y is inverse sine of x minus 2. Cool. Yeah? And last but not least, separate the variables equals dx. Natural log of the absolute value of y equals, notice there's no plus or minus, by the way. Not every problem has a plus or minus. So natural log of 4 equals 1 plus c. C is negative 1 plus log of 4. So natural log of the absolute value of y equals x minus 1 plus log of 4. Do we agree so far? Okay, now solving this, we're not out of the woods yet. Absolute value does not go away, it's still there. E to the x minus 1 plus log of 4, okay? Which means y could have been positive or negative, e to the negative 1 plus log of 4. And based on the initial condition of 1, 4, we choose positive. Would you add one more thing into your notes, please? On a multiple choice, rarely would you see that form. They would clean it up a little. How can it be cleaned up? Yeah, so definitely the e to the and the natural log are inverses in a fashion, so we want to get those two together. So how do I break this up so it's just e and natural log? How about this? What do you know about this? Add, right? Now we're actually going this way. So tell me what this is equal to. E to the x minus 1 times e to the natural log of 4. So a multiple choice answer might look more like 4e to the x minus 1. Okay? Alrighty. That is that. Differential equations, check. Do I have time to do one off the homework? Let's do it. Let's go to number 6. X dx minus y. X dx minus y dy equals 0. Find the general solution, unless I added a note. What is the general solution? Which makes this what kind of known graph? It'd be a negative if you move stuff to one side. So it's a hyperbola if they asked, but they didn't ask. 7. General solution, dy dx equals 4x cubed y squared. Again, find a general solution unless I added something in there. Yes, sorry. So did you get something like negative 1 over y equals x to the 4th plus c? Okay, cool. That's pretty much all the new ones. Should we do another one? Maybe a testing kind of question? Yeah, that's pretty easy. Let's go with 5. Is 5 on your paper? I didn't replace 5, did I? Okay, so f is this piecewise function, ae to the x plus sine of x. This is stupid. You don't have to write this down, but I hate how he gives the right side first. ae to the x plus sine of x for x is greater than or equal to 0, and bx for x is less than 0. Find a and b so that this is continuous and differentiable. Sure. Yeah. Did you get a 0? Okay. I was cooking myself out. All right, that should get you started. Have a lovely day.